Hey guys, how are you? Welcome back to the channel. Today is day 49 of Upskilling myself, and yesterday, that is day 48, I didn't solve any DSA problems because I was preparing for my on-campus recruitment drive. And yeah, I revised some aptitude questions as well as revised some core topics. So yeah, let's see the DSA problems that I solved on day 49. So the first problem is binary tree pre-order traversal. So first of all, what is pre-order traversal? So there are three types of traversal: pre, in, and post. So pre means first of all we print the node, then we go left, then we go right. In order, we go left, then we print the node, then we go right. And in post order, we go left, right, and print the node. So in this case, we have to find for the pre-order. So we have been given a tree and we have to output the pre-order traversal in the array format. So how to solve it? So first of all, we define a vector of int answer array. Then we create a function, which is a recursive function where we pass root and answer. Then we return the answer. So in this function over here, the base case is if root is equals to null pointer, then we return, and then according to the pre-order traversal, we have to push the root value into the answer. Then we'll solve for left, then we'll solve for right. It's that easy. So the second problem is binary tree in order traversal. So it's similar to the previous problem, but instead of printing the node first, we'll go left, then we'll print the node, and then we'll go right. So we're doing the same. We go left, then we push back the node into the answer, and then we go right. Rest everything is same. Okay. Then the final problem was task scheduler. So we have been given an array of CPU tasks, each labeled with letter A to Z and a number n. So let's simplify it. We have been given an array which has letters from A to Z and n is given as 2. So let's say if first of all we take a task A, so the next A should appear after a minimum gap of 2. So here can be anything, this can be anything, and then we can put A, right? Then the second letter is B. We can put B over here. Then this B would come after two positions, which is this, right? So this space would be idle, right? So we have to return the minimum number of CPU intervals required to complete our task. So we'll solve it using maxip and queue. So how to solve it? So first of all, we count the frequency of tasks. We define a map of frequency which takes character and its frequency, and we show the character and frequency to the map. Then we create a maxip for remaining counts using priority queue, and then we take the task and frequency from the map and then push into the heap. Then we define a queue to store task in cooldown. So the first argument will be ready time, and the second would be the frequency, which is the remaining count. Then we set time as 0, and then while the heap is not empty and the queue is not empty, we increment the time. And if there is a task ready to execute, then while the heap is not empty, we will define count as the top of the heap, and we'll pop from the heap. We'll decrement the count, and then if the count is greater than 0, we'll push into the queue, right? And also we will push the time plus n. So if the current time is 1 and n is 2, so 3 will be pushed alongside with the count, right? So 3 is the time when it will be ready to push in the heap. Okay. Now if the front of the cooldown is ready, then we'll push back again to heap. So pq.push cooldown.front.second, second means the value, and then we'll pop from the cooldown, and then finally return the time. Then for development part, I did some internship work. I also did the revision of operating systems and did the revision of all the DSA programs that I solved till now. So thank you guys for watching, and see you on day 50.